In this video, we're going to be taking a look at transition metal nomenclature, or how to name ionic compounds that have a transition metal in them. So why we have a slightly different idea for transition metals is that transition metals can have more than one charge. And so because of that, we need a way in order to recognize what charge that metal has. And the way that we do that is going to be through Roman numerals in order to show the charge in the name. And so these are going to be the different Roman numerals that are going to be most common that we use for different compounds. Let's go ahead and take a look at why these are needed. So in our first example, we have our iron, our FeCl2. Now this and everything is going to be our iron 2 chloride. And then in the next example, we have the FeCl3, which is the iron 3 chloride. Now, how and everything this is different is that the Roman numeral is going to represent the charge of the metal. So our Fe in this first example will have a +2 charge, and that is coming from that Roman numeral to the right of it. Now, in this middle example, our iron, our Fe, has a +3 charge, and that is coming from that Roman numeral to the right of it. So our iron can have two different charges to it, which is why these Roman numerals are needed for this. And then we have our CuO, which is going to be our copper 2 oxide. Now, our copper 2 oxide is a little bit more complicated. And so I'm going to go ahead and kind of go backwards with this. We're going to take a look at everything at the copper 2 oxide first. So we have copper being our Cu. It has a +2 charge, and we know that because of the Roman numeral. And then our oxide being the oxygen, oxygen having a -2 charge. And so what we get whenever we cross these down is going to be our Cu2O2. But if we remember about our ionic compounds, is that if we're able to reduce the subscripts, we need to. So in this case, we have 2 and 2, which can be reduced down to 1 and 1. And so we end up with our CuO as the final formula of this. And so our copper does indeed have a +2 charge to it, but in the final formula, because we reduce those subscripts, it's just a little bit harder to tell. So again, our FeCl2 has a +2 charge. Our FeCl3 has a +3 charge. And then in this last example, our copper will have a +2 charge. Let's go ahead and take a look at a few examples. So our first one is going to be our copper 1 oxide. So whenever we take a look at this, we have our copper being our Cu. Now it has a +1 charge to it because of this Roman numeral, so +1, and then the oxide being the oxygen. And our oxygen will have a -2 charge to it. We're going to cross these down, and we end up with our Cu2O. And this is going to be the formula for the copper 1 oxide. Let's take a look at the next one. This is going to be our copper 2 oxide. So our copper being our Cu, in this case it has a +2 charge to it. And then our oxide being our oxygen has a -2 charge. Crossing our numbers down onto the opposite side, we're going to end up with our Cu2O2. But we are going to reduce this down. Our 2 and 2 are able to reduce to 1 and 1. So we end up with our CuO as the final formula. Let's take a look at our next example. We have our tin for fluoride. So our tin, our symbol on the periodic table is Sn. In this case, it has a +4 charge to it. Then our fluoride, being the fluorine, will be an F, and our fluorine has a -1 charge. Crossing these down, we are going to end up with our SNF4 as the final formula. Let's go ahead and take a look at going the opposite direction. So we are going to have our MnO2. Now, this example is a little bit more difficult because of the Roman numerals for it. So how we're going to go ahead and take a look at this is that whenever we're going from the formula to the name, is that we need to uncross our subscripts that we have. And so our kind of invisible 1 has to go back up to the oxygen, and the 2 will go up to our Mn. And so what we would think is that this is our Mn with a +2 charge and the oxygen with a -1 charge. However, the issue arises with this oxygen. This oxygen does not have a -1 charge. Oxygen is supposed to have a -2 charge. So oxygen needs to have a -2 charge. So we need to change this -1 to a -2. And the way that we do that is going to be through multiplication. And so this is just a simple times 2 in order to change it from a -1 to a -2. Now, we have to do the exact same thing, though, with our metal. So our metal is at a +2, and so we have to multiply by 2 as well, and so we end up with our Mn +4. So this is going to be the true charge of our metal. Now, writing this out, our Mn is going to be our manganese. Our Roman numeral for 4 is going to be our IV, and then our oxygen becomes oxide. Now, if we kind of go back and double check with this, just to make sure everything is fine, we are able to go from the name back to the formula to make sure that this is correct. So we have our manganese, which is our Mn +4, our oxygen, oxygen -2. Crossing these down, we are going to end up with our Mn2O4, and then 2 and 4 are able to reduce down to 1 and 2. So reducing this down gets us to MnO2, which is the correct formula that we started with. And so we know for sure that the manganese 4 oxide is the correct name. And that is why this one is a little bit harder than the other ones. So taking a look at our next one, we have our CO2O3. So first thing that we're going to do is that we need to uncross these charges. And so we are going to end up with our CO +3, O -2. Now, if we take a look on the periodic table, our oxygen does have a -2 charge, which means that this is correct. So our CO is our cobalt. The Roman numeral for 3 is just 3 I's. And then our oxygen becomes oxide. So we get cobalt 3 oxide. Let's take a look at another example. So we have our NiBr2. First step is that we need to uncross our subscripts. So I end up with our Ni +2, Br -1. Now, if I take a look at the periodic table, our bromine does have a -1 charge, which means that I am ready to name this compound. Our Ni is going to be nickel. The Roman numeral for 2 is just 2 I's. And then our bromine will become our bromide. So nickel 2 bromide is going to be the name of this compound. And that is going to be how we take a look at our nomenclature whenever we have a transition metal for an ionic compound.